count us in, like hand clap.
Yeah,
You
give us the
grab
clapper.
yeah. Yeah.
Yeah.
Oh, I love modern technology.
Oh yeah.
As I
Yeah.
talk to you too.
Yeah.
Yeah, there was a
Amazing.
word that Yasha, that you used before when we were chatting, and now I'm so mad I can't remember what it was. I was like, "What did he?" That was Chinese. I have no idea what you just said. um, you like turned a noun into a verb, and now I'm mad I can't remember what it was.
Oh.
Voxing? No, you added ing to something.
Not
Oh,
sure.
voxelized.
Was that it?
Voxelized. That's right.
Voxelized. Yeah. Yeah. Like not pixel but voxel, but like instead of it being parametric, you just take a thing that's 3D and then you just like draw the cubes.
Yeah. Fill it with cubes.
Yeah.
Minecraftify.
Same thing exactly. Yeah. That's like the same thing.
Yeah, just smaller.
You say to the person who can't quite seem to get this live stream to go live. Okay, Andrew, let's go. Take us away.
Cool.
All right.
Let's do it. All right. Welcome everybody back to This One Time, where we talk about why hardware is so hard. And instead of just saying that out loud, we get into the nitty-gritty of it. We talk about what is it that makes hardware so hard, those details that kind of get swept, under the rug, kind of put behind the curtain. You usually see the great products that come out of these processes, but we're here to talk about what it's like being in the trenches.
Oh yeah.
And today we have a very special guest, Jasha Wilcox. He's a longtime friend, a former colleague, and the owner of MELD. It's a product development studio. Jasha is also the first external guest that we've had at Urban Machine, although you are a hardware advisor at Urban Machine, so you are connected to the company.
Yes.
And you have been in the trenches with us. You absolutely have been.
Absolutely.
Yeah, and of course, as usual, we have Jorie Wisnefski, our marketing manager here at Urban Machine, joining us. And yeah, today we're going to be talking about industrial automation versus new school robotics, sort of like the traditional old school stuff you see versus some of this new school, mostly on the software side. And we're going to talk about the interplay of these two worlds. Jasha has a lot of experience in this domain, so we're going to kind of tease that apart and get into it. So that's sort of the setup for today's episode. Yeah.
And, just to start us off, I am curious how you two even met, how you got involved working with us, Jasha.
Yeah, absolutely. And yeah, again, thanks for having me. I'm really excited to.
I'm so glad you came. Thank you.
To be a guest on the stream. So I feel
last time we had Sasha. This time we have Jasha. Next time.
There you
Sasha.
go.
Is there a costume?
Yeah. There you go. I'm trying to think. For me, I think it was Lemnos was the first touch point, and I know Lemnos through a friend from college. That's with Scythe Robotics, really cool company. Check them out. But I think we got connected through a partner there, or no, it was indirectly.
Alex Kolchinsky, I think, is my connection point into this. So we have a mutual friend, also sort of adventuring in the hardware robotics startup space.
Yes.
And this was probably like 5 years ago now or something.
Yeah,
like
that's right. 4 or 5 years.
Yeah, 4 or 5 years, in the before times, I guess we can say. And the three of us came together to start working. Alex had this idea for a mobile robot that you would stick in farmers' fields, and it would automatically do the task of weeding those farm fields.
Yeah.
So we were going to build this mobile robot platform.
And Alex was the software guy.
Alex was the software guy.
And we were we were the hardware guys.
Yeah. I had just worked on a couple of mobile robot platforms. You had a ton of experience also in mobile automation.
Yeah.
So the idea was we're going to come together, we're going to build this thing. And we started to build a prototype, right?
We did, yeah. And we rolled it around the Stanford campus, I remember.
We actually built, actually had a row of soy that we planted at the Stanford farm down there.
Yeah.
We had like we built this cart and we were driving this cart up and down this little like mock farm.
Yeah.
That we had down at Stanford. Yeah, I totally forgot about that.
Yeah,
That was pretty legit.
if anybody doesn't know, Stanford has like a farm on the campus. It's like a little mini farm, and they like loaned us 1 row. We were like, we just need 1 row.
Yeah.
Can we have a row? We're gonna plant soybeans. So like planted soybeans in a little row.
Yeah.
And we just rolled
Andrew,
the robot through the campus. Yeah.
That's amazing. First of all, let me just say that you're like living every little boy's dream. You're playing with robots. You're a farmer. You now drive forklifts. You're
Yeah.
It's pretty wild. Yeah, so that we kind of we got into that project a little bit, and we were, for a variety of reasons, we thought maybe this is not the best opportunity for us to go after right now. And then the 3 of us kind of like split ways. Alex sort of went off and started to do this like restaurant automation project. But we stayed in touch and started working on a variety of other sort of automation projects together.
Yeah. I would ping you now and say, hey Andrew, what's up?
Yeah.
And then I was like, one time I pinged him like, hey Andrew, you want to build a giant ag robot?
Yeah.
Moving crops around?
Yeah.
And then, so we had that summer.
Yeah.
That was really hardcore.
One of these extremely intense projects where we were down in Salinas, again working on a farm.
Working on the farm.
Yeah, working on the farm, being outside.
Burning the midnight oil.
Deep night oil. I think there was a couple times where we were driving back from Salinas at like 2 or 3 in the morning.
Yeah.
Like all the way back to Oakland.
We definitely were. But, because again, we're the hardware guys, and so I had some other team members up in the Bay Area remotely logged in and working on the robot. So some people didn't have to commute. Yeah. But we were definitely.
Yeah, you and I were there.
You guys were in it to win it.
Yeah.
Okay.
Yeah.
So then, fast forward, you, Andrew, I assume, reached out to Jasha.
So we were coming off of
this.
this.
Urban Machine was it? Like how far along were you in the
process? So we were kind of at the tail end of this ag project, and we built up a bit of a team to do this ag project, and actually I think you suggested Eric, the CEO of Urban Machine, my co-founder, we had collaborated on some projects before this thing with Jasha, and Jasha made the suggestion, hey, maybe you should reach back out to Eric and see how things are going over at Slingerson.
Like, what's up with Eric? It's
what's up with Eric?
It's been a minute. Like, what's going on?
So I messaged Eric, and that's when the whole Eric messaged back and said, well, funny enough, I'm thinking about this lumber reclaiming thing, and that was kind of the tip off there.
Timing is everything.
The timing is everything. Yeah. So that was summer. That was like midsummer 2021. Now, so like almost 2 years ago. When and then we had you were there.
The first meeting.
The first meeting. Eric
at Circuit Launch.
At Circuit Launch, Eric came down. He brought a handful of pieces of lumber and some of these old school hand tools, and pneumatic shooters, and all that. And the 3 of us were in the basement at Circuit Launch, just messing around,
pulling nails out. Literally.
How's this gonna work? Yeah. So it was right.
Who knew that less than 2 years later?
Yeah.
Incredible progress.
Yeah.
It's been amazing.
So that was initial. Here's kind of an idea, and 2 years later, we've deployed a full system in the field. It's operating right now. As we speak. It's up there chunking through lumber.
Yeah.
It's awesome.
Yeah.
Okay, so today's episode is really about melding that old school machinery and industrial machinery, right, with today's nuanced software. How do we do that? How is it a problem that for us to solve at Urban Machine, and what are you doing about it?
Yeah. So
3-part question.
I think even pretty early on, Jasha, you had this sort of concept of this movement that was happening that you coined new bots.
Yeah, I've tried to put some coinage around it, calling it new bots or new botics. And a lot of that for me just comes from, the software people get their own revisions on a lot of things. So we have like Web, 1, Web 2, Web 3. And so like, why don't roboticists really get that? And like, is there anything we can point to specifically to kind of like say this, chapter of the book is kind of concluded or started? And so that's the thing that I'm like calling new bots. Like let's talk about this new generation, new wave of robotics. And I'd say like the tenets that embody that. The first is usually it's low reliance on infrastructure. So we try to not modify infrastructure, and we try to build a robot that can just use existing infrastructure. And the reason for that is there's a lot of applications and verticals where the infrastructure can actually be way more expensive than the robot interacting with the infrastructure if you're building something new. So like you start with, a pile of dirt and you need to build like a warehouse. But building that warehouse is going to be way more expensive than the robots that actually live in the warehouse.
Yeah.
And so just recognizing that and that in a lot of the business cases, I think this highly incentivized, more flexible robots. Because like if the robots cost 2 or 3 times as much, it could still be 10% of the total build out.
Yeah, so an example of this might be if you need to put a large industrial robot arm in a facility that might not be designed for that, you might literally need to carve out and excavate the floor to pour a new concrete pad with mounting points for the arm. Like a major construction project that could take at least several months, and all this infrastructure you have to build out just to set the scene to install the automation.
Yeah.
Right? Yeah.
So yeah, the first one is infrastructure versus making the robots kind of like work around existing infrastructure or less complex, cheaper infrastructure. And like the really big one that comes out of that is mobile robots. So robots being mobile is now like a thing that we're seeing more and more. That I think like the canonical example is Kiva Systems down in Amazon Robotics, where you have like these kind of adaptive AGVs moving stuff around in the warehouse application. The second thing though is parallelization, I would say. So smaller modular systems or robots that are orchestrated in parallel to actually reach the required throughput. Because usually you buy like one giant machine that goes really fast.
Okay.
But a lot of these new applications, you buy a bunch of cheaper, smaller machines in quantity, and then their collective parallelization has a similar throughput. And I think my favorite example there is a company called Tavel. They make like citrus harvesting robots, but they're actually little tethered drones. So like instead of having a machine that can pick in cereal like one apple at a time, you just give it like 40 drones that can all kind of like slowly grab and pick apples, but in parallel the throughput is actually adequate. Urban Machine also follows this rule a little bit in a modular approach to the system.
Yeah, so for example, our system, instead of having one large arm navigating around the wood, we have these much less expensive gantry systems, one for each side, so we can pick multiple sides simultaneously. Sure. And then each module, of course, we can just stack more modules in line, process more parts of the wood.
Exactly.
In parallel.
Sure. I mean, it's efficiency, of course. Like
it's also another sneaky thing that you get from this is also redundancy, because it's like a swarm approach. If one little bit of your swarm gets knocked out, the rest of the system can still perform its action. So you're robust to fit. Like the modularity gives you robustness in your execution. So that's like another sneaky aspect of it.
Yeah.
It's kind of funny that you just said swarm approach, because in my mind I was picturing like one bee, collecting pollen versus the whole colony. Like,
absolutely.
Okay. Perfect.
Yeah.
Exactly. Yeah.
Like when my kids help me do the dishes versus I do it by myself.
Yeah.
Yeah.
Just like that.
Uh-huh. You'll get there, Andrew. You'll get there.
Just a little more.
She needs to reach the sink first.
Yeah.
Okay.
Yeah.
Sorry. Go ahead.
Let's see. I was just gonna say for the kind of the new bots thing, the third tenet. So the first is low infrastructure / adaptability. The second is modularity, and then the third one it really varies, but the third one is really, I would say, leveraged by how we design a lot of robots now using modern tools such as additive manufacturing. And so kind of like one robot that I would consider to be like a new chapter in robotics that isn't I would say like discussed so much is really how successful the Roomba is and how significant it is as a robot. Like the Roomba is the like most sold robot ever in any application, and
Right.
like in terms of hours in service, it's like the most successful robot we've ever made. And like a big reason for that is that it's injection molded. Like it's an injection molded robot made out of plastic, and it that enabled it to meet all like really be widely used. And the Roomba is really relevant right now because with all of the AI stuff that's going on, there's a lot of money going into humanoids, and the humanoids are kind of like what I would consider to be a Roomba that grew an arm.
Yeah.
And so, yeah, so now it's like not just moving around, but it's the mobile manipulation. And there's like the humanoid here versus the Roomba that grew an arm. There's this middle ground, but a lot of that can actually be made with cheap parts like plastic and motors that are getting even cheaper. And so I'd say like modern tools, modern approaches, especially with additive manufacturing. Like we're seeing a lot of 3D printing doing interesting things in robotics. But
Yeah, and you can like taking some lessons from consumer electronics
Yes.
and like what mass manufacturing looks like there, and injecting it into automation, and realizing that we're not assembling automobiles. We don't need sub-millimeter precision for these new wave of automation tasks. That sub-millimeter precision, the more precise you need to get, it gets exponentially harder. So that's why you see these robot arms cost hundreds of thousands of dollars, because of these huge, extremely heavy, extremely powerful, precisely machined components that allow you to get that. But then that's the only thing that you have access to perform automation. So you don't need like 0.04 precision to go pick up a towel off the floor.
yeah.
So you can sort of take those lessons and back them out.
Exactly. So yeah, I'd say that's kind of just to embody the recap. There's like the first is low infrastructure, second is modularity, and then the last is making it cheap with cheap materials, cheap processes. Using like again, additive allows us to consolidate lots of parts into fewer parts, and that's something that I think we're seeing more and more making robots.
Well,
So
and
how
let
do you-
me ask you a question just about cheaper parts. Like I was talking with a friend the other day who said she has a Dyson, back to the vacuum, and she said that the motor itself is amazing, but the plastic parts break. So how do you balance that? Like these cheaper parts, because you have to keep your costs down low, but are they so cheap that they break?
Yeah, I mean, I think the stuff breaking like that just gets into like my thing, and I know I push you a lot, Andrew. Is just like test it.
Yeah.
Like you just gotta test it, and
Yeah, test its outer limits.
yeah. Another great example, like Machine does a great job of just testing stuff, and because you learn so much that you could never figure out from just
Relentless.
whiteboarding it,
Yeah.
Like, and with the farm stuff too, it's just like
You're doing it every day.
you gotta get out there and see it move, and then you're like, oh, okay. But like a good
That's
example is, yeah, and like culturally, Boston Dynamics, they're not afraid to break the robots at all. Like that's a tenet. That, like, it's okay to break the robot.
Yeah.
Versus a lot of like R&D, or I think in academia a lot, there's a lot of hesitation to like get out there in the dirt and the grime and actually just like see it fail. Because like yeah, it's gonna break, and like every time it breaks, if you have a really short cycle on updating the design, you can make the spot that it broke before stronger, and you
That
do that enough
protects you too,
times, and you
right?
have a balanced design, right? So it's like the plastic broke because the motor didn't break, but then the motor was like overheated, and you can just kind of go back and forth until you have a nicely balanced design.
Absolutely. Lessons learned from mistakes. I mean, I think that's
Yep.
that's life in general. So why
Yeah.
wouldn't it follow suit in robotics, right?
Yeah, and the most important thing is just not saving it all up to the end with some
Yes.
giant waterfall process. Where on the last step of our Gantt chart, we will then test the system. Like that doesn't. There's no reality that exists within. Yeah, it's more of a Theseus's robot setup.
Yeah. Yes.
Yeah.
And in something like their machine application, that it's like It's a big, heavy, serious, like really complicated. You never quite know what's going to go into the machine, right?
Yeah,
Very high activity.
Yeah, the fundamental challenge we have is just the inputs are infinitely variable.
All
right?
over.
Yeah, that poses all sorts of challenges.
Long tail.
Yeah, long tail of stuff. Yeah. So another, I'm curious. You didn't have this on your tenant list, but like compute and perception are two big pillars that have come up that have enabled a lot of applications in the last few years in robotics. How do you see that landscape, and especially how that sort of contrasts with more traditional industrial automation that you might see in a manufacturing facility?
Yeah, totally. This is also a good segue into the like traditional automation technology and kind of modern robotics and the tension that exists between the two. Yeah, in terms of tenant, I didn't say that because it's kind of like the governing principles and observations about the world that I would say like where new bots exist, but then there's the actual technical things and solutions that have leveraged it. So I did mention 3D printing, but the best example of like where does compute come into play, I think, especially, and you mentioned it already, is accuracy and precision. So in a mobile robot that's not bolted to the floor, you can't just go to the same place because the whole robot is no longer registered to the thing. If you want to move two objects together in relation to each other, if they're both bolted to the same floor, it's really easy because you just get a robot that's really precise and very expensive, and you just program it, go to this coordinate in space, and it does that for years and years and years, and it's really easy. But it's really kind of a simple system. It's not very smart. If the robot's mobile, it has to actually like perceive the world and know where it is and then re-register it between these objects. And so this fundamental requirement for adaptivity necessitates perception and compute to have evolved, which it has today. It's been highly subsidized by cell phones and autonomous cars. A lot of money has gone to autonomous cars. Sure. It gives us all of this beautiful compute from companies like NVIDIA building the Jetson, and then also just like cameras. Cameras are just so much better.
Yeah,
so
we're a direct benefactor of this at Urban Machine, where and even just a couple years ago, like we're looking at a new camera option right now. When we first started this, we had narrowed down the field to one system, and now there's a handful of systems that we can choose between that have even better capabilities. Even just since we started the company, that's how quickly it's changing.
Technology evolves.
Yeah. And a few years ago, I don't think you would be able to run the perception stack that we're running. The technology just wasn't there.
And that's the crazy thing is like, so gearboxes are the most expensive part of like an industrial robot arm, and it's really hard to get that cost down versus the compute is the marginal cost of that gearbox being precise. So it's like, we're trying to make the sand think. So we're getting really good at making the sand think and making all these computers and, graphics cards and things get really, really fast. But if we can actually use just a camera and a processor to compensate for this lower precision gearbox, this cheaper casting, this part that used to be metal but now it's plastic, so it's bendy and flexible and weird, we can now have software start to actually compensate and still achieve the same performance with cheaper hardware. So it's like software eating hardware is really kind of like what's emerged out of this, and that's part of like what you see in a new bot system, I would say. A good example of that in industrial arms is this company, they make prototype metal parts instead of punch dies.
Oh, is this the LA company?
Yeah.
That does like the sheet metal. Oh God, what are they called?
They're really cool. I was listening to a podcast and they were talking about how their application runs robot arms like at a lot of the limits. So like the whole robot actually flexes, like the metal flexes so much that it's no longer like within, or it's usually almost out of the precision of the normal movement. So they actually are doing a lot of their own like compensation and figuring out how to like compensate for that because they're pushing it on the edge. Okay. So like imagine the solution that they're making there in software, apply it to a robot that's now made out of less stiff material that's like really cheap.
Mm-hmm. Well, back to you were saying before that there's this school of thought, don't break it, just treat it gingerly and all that, but then like the people who are willing to break it to learn from it. I feel like there's been a shift to the louder in general. Do you feel like that's helped things progress? Like what you're saying with these pushing the limits, people aren't as afraid of failure because they learn from the failure itself. Failure is a strong word, but you know what I mean.
Maybe this is a good time to talk about the industrial automation versus modern robotics. So like, I think one of the key things about industrial automation that you'll come across is how reliable it has to be. It's like a good example is there's this company I remember. So like when you're running like a car factory, there's like the line where it's one additional part you put on. But the issue is if any single thing fails on that line, the entire line is down, and then it's like tens, hundreds of $1,000s a minute because like the whole facility is stopped. And so there's this company that makes a piece of equipment to inspect screws. Because if you have a screw break off in an engine block at the Ford plant, it's very expensive. Because then like that car has to like get, it's no longer, can't use it anymore. It's hard to get it out. So there was an entire company built around just inspecting screws. I think it was called Mectron High-Speed Inspection Systems. But they made this machine that it would almost drop the screw through the air, and it would scan the profile of the threads and like use magnetics to actually make sure there are no cracks in the screw. And it was so high value to just inspect the screw to make sure none of them were bad that's like there's a whole company that exists to like inspect
carve out just for this one little
to
thing.
inspect this thing. So like what I'm getting at, a lot of the industrial automation is built around being reliable because that's not an option. A lot of the industrial automation stuff has really, really long service lives, like 10 years. The Oreo machine that mixes up the cake and then the filling. Like there's some like PLC that's like controlling that mixer, and that thing's probably been sitting there for a long time.
Yeah.
A long time, and the person that initially installed it doesn't work there anymore. So when it breaks, a new person has to come see that machine and know how to fix it really quickly. So it's like it has to be super reliable and super easy to understand if you just walk up to the machine.
Right.
And neither of those things are true in like kind of an academia robotics concept or a lot of a lot of things are just getting so complicated now in robotics that you can't just walk up to a machine and understand it. Like imagine walking up to a cruise automobile and like understanding like how does this work? Like you can't just look at the thing. But for the really simple thing that's like mixing the slurry for the Oreo, you can. There's like the ladder diagram and these old school, old crusty industrial automation tools that are really easy and robust. And like I don't know about you, but like, I haven't met many software people or people in robotics. A lot of people don't even know what a ladder diagram is.
Yeah.
And if they do know what it is, it's very like. It feels improper.
It's not. It was designed in a world where modern software approaches hadn't been thought of yet, or a lot of these modern software languages we use now didn't exist then. So these ideas of like agile software development, collaborative development, having shared repositories that people are committing to,
revision control,
continuous integration and release processes, like all this infrastructure that modern software has developed to make their process faster to iterate and deploy on, does not exist in that in the Oreo plant.
In the Oreo plant, it just hasn't. And so like the kind of like the system requirements, or like I wouldn't even say system requirements, the requirements that are like paramount to an entire industry is like reliability and serviceability. Like all this industrial automation, if you're a company in that space, that's what you're building for. Versus like robotics, and especially urban machine, we talked about how there's this long tail, and it requires adaptivity. So like the Oreos, there's very little adaptivity required in the system. It's very consistent and like a lot of products that we make, the whole objective is to make the same thing
Yeah.
consistently.
Yeah.
Right.
Urban Machine has to deal with just like weird stuff.
Yeah.
Yeah.
And that
it's just all over.
Yeah, and that defines a lot of the challenges that folks developing robots today are working on, is just high variability. That's sort of you mentioned the capabilities and perception that we've seen that's enabled us to go tackle this new class of problems. These new class of problems necessitate all the infrastructure, the software infrastructure
Yes.
that has come out of software development over the last, call it 15 or maybe 20 years, right? So we have all this new modern software infrastructure that allows us to do all these incredible perception tasks and understand how to make these automation platforms more agile to the various inputs, right? But that informs nothing about how reliable a system is going to be when you implement it. And that's the tension, right?
Yes.
Like that's where the rubber hits the road. That's the real tension there, is that you need the reliability of the crusty old system working in the Oreo plant, but you need the adaptability and the flexibility and the development paradigm from the modern software world.
Exactly. And this comes up with like, you have two systems that are mixed, is usually what it looks like. So machine like this, there'll be some of it is all off-the-shelf industrial automation components and that stack, and then you'll actually have this, usually the robot operating system comes up a lot with people developing robots from kind of like a more Silicon Valley perspective. So then there's like some computer running that, and then the two systems have to talk.
Right.
And there's an entire challenge of like defining the system boundary cleanly and having hardware interoperability. There's a whole group called Ross Industrial that deals with this. It's like Ross going into these applications. Ross Industrial is like, this isn't a problem that's solved, and it's a problem that a lot of people have now, building these sort of industrial applications, but require really weird perception and really weird manipulation and that adaptivity that you can't get with an off-the-shelf industrial system.
Sure. It's like the odd couple. You've got like
Yeah. Exactly. Yeah.
one that has to be consistent and one that has to be able to,
Yeah, and if you want a modern software team to freak out, just take them through like a ladder logic.
Yeah.
And like, oh, what do you mean I can't like just spin up a GitHub repo to drop this all in and collaborate?
Yeah. It's gotten better. Like I think there are companies on the industrial side that get it a little bit more. Like we were talking a lot about. What I would consider to be companies that get it and are a bit more modernized, or B&R Automation and Beckhoff. Because Beckhoff, the thing that's kind of weird about them, or weird for the industrial automation industry, is their control runs on a computer, like an actual computer, and they sell you like the actual PLC includes a computer, and that was kind of a weird one for the industry, and it allows you to do things like have revision control, maybe.
Yeah, they do allow that
on the thing. And then we were talking about code assist earlier, which is like a standard that encompasses more than just ladder diagram. You have structured text, which is a more formalized language, but still in the industrial automation realm. And a lot of the vendors have like bought into that standard, so they can actually run it on their hardware. But
so in your role, Jasha, in your role at with helping advise, are you helping balance this between the systems?
I don't know if I'm helping, but I try to ask a question.
Point us in the right
Yeah. Yeah, certainly. Because this comes up in a lot of the stuff I'm working on just all the time, and like a lot of what I do, I think is trying to bridge the worlds a little bit, and so I'm definitely always trying to be like, hey, like this is the thing I heard about. Like, would this make sense to look at for the urban machine application to be better?
Cool. You're like the flexi metal.
Yeah.
Awesome. Well, I really appreciate you being on our show today. Thanks for being our first offline or out of pocket, whatever guest.
Yeah.
Absolutely. This was so fun, and
You're still
yeah.
wearing your swag, so thank you.
That's right.
Yeah, for sure.
Just hooked up.
It's a
Yeah.
good lid. I love it. Andrew, you're hiring right now. You
Yes,
wanna
we are. Yeah, please
plug what
check
we're
out.
hiring?
You can find job posting either on our LinkedIn page or at urbanmachine.build. We're always looking for talented folks that want to work at sort of this intersection of automation, machine design, and sustainability. That's what we're all about here. So if that sparks your interest, please reach out.
Absolutely. And you can check out our robot on YouTube, on LinkedIn, on our
Yeah,
website.
absolutely.
Yeah,
And if you're coming up with a new hardware product, you might need help putting things together.
Yeah, certainly. Tell me about your problems, and yeah, we can talk bots anytime.
Yeah.
That's right.
Yeah.
And what's
Where can folks find you?
yeah, Yasha, how can they reach you?
You can hit me up on LinkedIn, and then yeah, LinkedIn or website. I'm pretty easy to find. Yeah.
Okay, that sounds good. All right, well, until next time. Next time we're going to be talking about reclaimed lumber at Albay with Eric and Frank from Albay.
Yeah, it's gonna be a fun one.
Yeah, for sure. All right, thank you guys.
Super. Thank you.
Thank you.